Radhe Radhe. So in this video I'm going to discuss the find the median of uniqueness array, whatever it was, in the LEETCODE challenge problem, which occurred in today's LEETCODE challenge problem. So if you have any doubt regarding this, you can pick me up on Instagram. Even you can join my Discord server. I put both the links in the comment section. I'll pin them. Problem statement is very simple. You're given an array and you have to find for all sub arrays the number of unique elements and sort it, and you have to find the median of that array. Okay. So basically, I won't explain the question further. I will just explain the gist of the solution. So what you can do is, over here in the solution we need the binary search and a sliding window. Okay, so let's say the binary search and sliding window. So how the binary search looks like? The binary search looks like left, right, while left lesser than equal to right, whatever it is. Okay, somewhat like that it looks like, right? So for that you can do one thing: find the mid, you know the formula, and check if sliding window of nums comma mid, it is lesser than n into n plus 1 by 2 plus 1 by 2. So this plus 1 by 2 is because of the median thing. Okay, and n into n plus 1 by 2 is the number of sub arrays possible for that number. So basically, so if it is lesser than this, then you have to modify left as mid plus 1, else you have to modify right as mid. Okay, and remember one thing, at the end you have to return left. Now this is the binary search portion. Now what is the sliding window search portion? Okay, so sliding window search portion, so since it is nums comma, let's say k, because now I'll like explain you what k and this thing is. So this thing, sliding window, basically calculates the count of the distinct elements for each window size k. Okay, so let me I think it will be better if we move on with an explanation, since we need to like reduce the time limit. So you can have a frequency array, and you know that the size of the array should be 10 to the 5 plus 1. Okay, because, or 10 to the 5 you can also write, because the range of the nums I is 10 to the 5. So you can do this. And then the sliding window, it's the same thing: left initialize as 0, right as 0 2, and then make while sorry, not n, right is lesser than n. Okay, what is n? N is the size of the array nums. So while right is lesser than n, now remember one thing, you have to like check the number of unique elements. Okay, the number of unique elements. So if, like, let's say if the frequency element, so like let me write it better. Okay, if frequency of nums of right is actually equal to 0, that means there was no other element, but after we insert that element it is going to be greater. So you can say that there is one unique element added, unique plus plus, and frequency of nums right plus plus. Okay, now there's a twist in the tail, that is sorry, the unique elements, in case it is greater than k, it has to be equal to k. Okay, simple. So how you're going to make it equal to k? What you can do is you can make left plus plus. Okay, and similarly for left plus plus, you have to check if the frequency of the left element after decrementing it is equal to 0, so the number of unique elements also decrements. Okay, and basically what you have to do is, for this part we were incrementing right. Okay, right plus plus, and for this part we are incrementing left. And once we are done with this part, so what we can say is, so let's say we also had for the sliding window we had answer equal to 0. Okay, so now answer plus is equal to right minus left plus 1, that is the size of the sliding window, I mean size of the window. Okay, and similarly after this also you can make right plus plus, just because you need to like shift that element once. Okay, and after we are done with this, like after this recursive function we are done with this while thing, so we can just return answer. Okay, like I can go for the dry run, but I think that will be a too lengthy process, so you can go for the dry run and check the logic behind the thing. So this is basically what it is. Okay, so binary search, find the optimal solution, and the optimal solution is stored in left, since left is equal to mid plus 1, and at the end return left. And for the sliding window portion, you're going to have a frequency array, a left, right, the sliding window, and in case the number of unique is greater than k, so you have to like make it k, and then increment left, and then increment right, and we go on doing it. Okay, so that's it from my side. Thank you.